Lesson 6.3. Our objective is to solve a system of equations by using the elimination method. Guidelines for solving a linear system by using the elimination method. Number 1. Arrange the equations with like terms in columns. Number 2. Examine the coefficients of x and y in both equations. If needed, multiply one or both equations by a specific number so that the new coefficients for x or y are opposites. Number 3. Add the equations and solve for the remaining variable. Number 4. Substitute the value found in step 3 into one of the original equations and solve for the other variable. And number 5. Check the solution in each of the original equations. In the previous lesson, you learned how to solve a system of equations by using the substitution method. In this lesson, you will learn how to solve a system of equations by using the elimination method. Our goal is still the same. We're looking for an ordered pair, an x and a y value, that will work in both equations. Okay, so now the first thing that we're going to have to do if we're using the elimination method is we need to arrange our equations with like terms in columns. And when I look at it, I'm looking at the column. I see here my x's are already lined up and my y's are already lined up. So step 1 is done for us. Everything is already lined up for us in columns. And then the next step says to examine the coefficients for both the x and the y, and if needed, we're going to multiply one or both equations by a specific number so that the coefficients for the x or the y are opposites of each other. Well, when I look at it, let's take a look at the y values. I have a positive 10y for the top equation. For the bottom equation, I have a negative 10y. Well, that's what I want. In order to use the elimination method, that's what I need. I need the coefficients to be opposite of each other. In the top equation, I have a positive 10y. The bottom equation, I have a negative 10y. So this is perfect for the elimination method. The first two steps are already done for us. Now I'm going to combine my terms going down. So I'm going down. Combine the x's and combine the y's. So first I'll have 6x minus 10x gives me a negative 4x. And then I'll have 10y minus 10y as 0. It cancels out. That's exactly what I want to happen if I'm using the elimination method. I'll bring down my equal sign, and I'm still combining going down in columns. I have negative 4 minus 10. That gives me a negative 14. So at this point, all I'm doing is solving for x because the y's dropped out. So I'll divide both sides by a negative 4. This leaves me with x is equal to a negative divided by a negative is a positive. So that's 14 over 4. Now I can reduce 14 over 4. I can factor out a 2. So this leaves me with 7 over 2. So for my x value, I have x is equal to not negative, but a positive 7/2. Now that I know the x value, I'll take that x and substitute it into one of the original equations. It doesn't matter if you use the top equation or if you use the bottom equation. You still get the exact same answer. And I think I'll substitute mine into the top equation. So the top equation was 6x plus 10y equals a negative 4. So when I get here to the x value, instead of putting x, now that I know x is equal to 7/2, I'll replace that with what I know x to be. So this becomes 6 times 7/2 plus 10y equals a negative 4. So 6 times 7/2, that's going to be 21 plus 10y equals negative 4. So now I'm just solving for y at this point. I'll subtract 21 from both sides of my equation, leaving me with 10y equals a negative 25. Divide both sides by 10 because I'm solving for y. It leaves me with y is equal to a negative 25 over 10. Now once again, I can reduce that. I can factor out a 5. And if I do, that will leave me with a negative 5 over 2. So for my solution, remember that it's an ordered pair, so I'm writing it as an ordered pair. The x value was 7 halves, and the y value was a negative 5 halves. Now let's take a look at our next example. Now for our next example, it's going to be basically the same as our first. In example 1, I set all the problems up perfectly to be solved using the elimination method because I wanted you to get some practice working the problems without having to do any changes first. I wanted you to get comfortable with the method first. Okay, so when I look at the next one, I'm doing the exact same thing. I'll check to see. You'll see that everything is already lined up in columns. So that's done for us. Also, if you look to see, this time the x's are opposite. The coefficients for your x's are already opposites of each other. So you didn't have to do anything there. So you're already ready to go ahead and solve the equation. So once again, I'm combining like terms, going down in columns. I have 3x minus 3x cancels out. And I have 8y plus y. That gives me 9y. Bring down my equal sign. And negative 4 plus 13 is 9. So at this point, I'm solving for y. My x is canceled out. I'll divide both sides by 9. That leaves me with a y is equal to 1. Now that I know y is equal to 1, I'll substitute that back into one of my original equations. Once again, it doesn't matter which one you substitute it into. I think I'll use that top equation again. You can use the first or the second equation. It doesn't matter. You'll still get the exact same answer. So for my first equation, it was 3x plus 8y equals negative 4. And since this time I know that y is equal to 1, I'll replace that y with 1. And I'll finish the equation. So this becomes 3x plus 8 equals negative 4. I'll subtract 8 from both sides, leaving me with 3x is equal to negative 12. Divide both sides by 3. That leaves me with x is equal to negative 4. So now once again, my solution is an ordered pair, so I'm going to write it as an ordered pair. My solution is negative 4, 1. Remember, it's an ordered pair, so you must put your x value first. Okay, now I want you to pause the video and try the remaining two problems in this very first example by yourself. Then restart the video after you're finished so you can check your answers. Have you restarted the video? That means you're ready to check your answers. And remember, before I said that all of the problems in example 1, they're already set up perfectly to use the elimination method. They're already set up for one of the variables, so you could go ahead and eliminate one of the variables. And in this case, for the next system that we have, we're going to eliminate the y variables first. That's because with the top one I have 7y, the bottom one I have a negative 7y. They're already opposites of each other. So everything else is already lined up. So I can go ahead and solve this system. I already have my columns lined up. So I'll go ahead and combine terms going down. So I'll have a negative 6x minus 4x, which leaves me with a negative 10x. A 7y minus 7y cancels out. Bring down my equal sign, and negative 11 minus 19 gives me a negative 30. So I eliminated the y variable, so I'm solving for x. I'll divide both sides by 10, negative 10, excuse me, leaves me with x is equal to a positive 3. Negative divided by a negative is a positive. Okay, so I have my x value. Once I get the x value, I'll go back to one of the original equations. Once again, it doesn't matter which one that you use. I'm using this first one again. It doesn't matter. You can use that second equation if you want to, but you get the exact same answer. So now that I know x is equal to 3, when I get to the x value here, I'll replace that with 3 because we found, oh, let me change that color. We found the value of x, so instead of using x, we can use the actual value now. So now at this point I'm solving for y. Negative 6 times a positive 3 is a negative 18, plus 7y equals negative 11. I'll add 18 to both sides. I'm just solving for y. That leaves me with 7y is equal to 7. So I'll divide both sides by 7. That leaves me with y equals 1. So that means that for my solution, I'll have the ordered pair 3, 1. Now let's scroll down and we can check that last one. Okay, once again, everything is already set up perfectly so that you can go right ahead and eliminate one of the variables. Have your columns already lined up. It's done perfectly. This time we're looking at the y values. We can eliminate those. I have a negative 5y for the first equation and a positive 5y for the second equation. So those will be easy to eliminate. So I'm ready to solve the equation. Once again, I'm going down. I'm combining terms going down in columns. I'll have a 4x minus 3x, leaving me with just 1x, so that's just x. And negative 5y plus 5y is 0. It cancels out. Bring down my equal sign. And then I'll have 21 minus 17 leaves me with 4. So that means that x is just equal to 4. Okay? Now that I know x is equal to 4, I'll substitute that value back into one of the original equations. And since for all of the others I use the top equation, this time I think I'll use that bottom equation. So this becomes 3 times. Now that I know x is equal to 4, I'll replace that with a 4. So that'll be 3 times 4 plus 5y equals negative 17. Negative 3 times 4 gives me a negative 12 plus 5y equals negative 17. So I'll add 12 to both sides. It cancels out. So that leaves me with 5y is equal to negative 17 plus 12 leaves me with a negative 5. So I'll divide both sides by a positive 5. That will leave me with, well, let me fix this. This kind of looks like an x. So that will leave me with y equals negative 5 divided by a positive 5 is 1. Negative 1. So that means for my solution, my ordered pair is going to be 4, negative 1. For example 2, we're going to multiply one of the equations by a specific number so that either the x or the y variables become opposites. Well, in our first example, we were fortunate enough for one set of our variables to already be opposites. But when I examine my variables in this case, for my x variables, I have a 5x for the top equation and a 3x for the bottom equation. In order for them to be opposites, one would have to be a 5x, the other would have to be a negative 5x, or vice versa. a 3 and a negative 3 for the coefficients. We don't have that there. Now for my next one, for the y variables, I do have a 2y and the bottom is a negative y. Well, one is positive, one is negative. That's good. However, in order for them to be complete opposites, one coefficient would have to be a positive 2, the bottom would have to be a negative 2. That's what I'm looking for. Okay? Now, what I'm going to do is I'm going to multiply the bottom equation. I'm going to multiply this complete bottom equation by positive 2. The top equation, I'm going to leave it alone. I'll go ahead and rewrite that now. Going to leave it alone. So it's going to stay 5x plus 2y equals 7. My bottom equation, now once again I'm going to multiply the entire equation by 2, will become 6x minus 2y equals 26. Okay, and all I did, I took this 2 and I multiplied it to each term in that equation. That's all I did. Okay, so now I'm ready to solve the equations just like I did in example 1. I'm going down, combining like terms. 5x plus 6x will give me 11x. 2y minus 2y, that cancels out. Bring down my equal sign. And 7 plus 26 is 33. I'll divide both sides by 11. 11's cancel out. That's going to leave me with x is equal to 3. Now that I know what x is, I can take that x value and substitute that back into one of the original equations. I believe I'll use that second equation again. The original equation was 3x minus y equals 13. And now I know what my x value is. So I'll make that substitution. So that becomes 3 times 3, because now I know that x is equal to 3, minus y equals 13. 3 times 3 is 9, minus y equals 13. I'll subtract 9 from both sides of the equation. That leaves me with a negative y is equal to 4. Well, I don't want to know what negative y is, so I'll divide everything by negative 1. That leaves me with positive y is equal to negative 4. So now here I have my solution. So that means that my solution is going to be the ordered pair. The x is 3, the y is negative 4. So it's the ordered pair 3, 4. Now if I wanted to look at my next one, I'm going to move this down, move it up, excuse me, so I can take a look at my next equation. Okay, for this equation I have 16x plus 4y equals a negative 28, and a negative 8 plus 8x, excuse me, a negative 8x plus 8y is equal to a negative 16. Now, once again, I'm going to do the same thing. I'll examine my variables. For the x variables, I have a 16x for the top equation and a negative 8x for the bottom equation. I could very easily turn those into opposites. And when I look at the y variables, I have a positive 4y for the top equation and a positive 8y for the bottom equation. Well, I could very easily turn those into opposites. In order to turn the y variables into opposites, I could multiply the top equation by negative 2, which would turn my y coefficient into a negative 8, forcing those two to be opposites. However, I don't think that's what I'm going to do. Now, when you're doing this, all you have to do is examine them and just make a decision on which one you want to change. It does not matter which one you change. because you're going to get the exact same answer. However, in this case, I think I will multiply this bottom equation by a positive 2. Once again, just like on my last one, I'm not going to do anything to the top one, so I just need to rewrite it. It's going to, excuse me, I want to keep that in blue. Change my color. I'm going to keep this as 16x plus 4y equals negative 28. Now my bottom equation is going to change because I'm going to multiply each term by a positive 2. Okay, so this will become 2 times the negative 8 will become a negative 16x. The 2 times the positive 8 will become a positive 16y. And then the 2 times this negative 16 will become a negative 32. Now I'm ready to solve the system. I'm going to do it the exact same way. In this case, I'll have a 16x minus 16x cancels out. I have a 4y plus 16y. That will yield a 20y. I'll bring down my equal sign. And negative 28 minus 32 gives me a negative 60. It's a fairly simple process. I'll divide both sides by 20. So this leaves me with y is equal to negative 3. Now once I have that y variable, all I need to do is simply substitute that back into one of the original equations. This time I think I'll substitute that back into the top equation. So the original top equation was 16x plus 4y equals negative 28. And now that I know what the y variable is, I'm going to substitute that with a negative 3. Okay? Fix this. It's a negative 3. And then I'll bring down the equal, just rewrite the equals and the negative 28. And I'll just solve this like we did in Unit 2 when we were solving equations. So this is 16x plus negative 12 equals a negative 28. So I'll have to add, since this is a negative 12, I want to add 12 to both sides of my equal sign. So this becomes 16x is equal to negative 16. I'll divide both sides by 16. And it leaves me with x is equal to negative 1. So for my solution, for this particular problem, it's going to be the ordered pair. My x is negative 1 and my y is negative 3. That's my final answer. Now what I want you to do is, I want you to pause the video, try the next 2 problems by yourself, then restart the video so that you can check your solution. Fairly simple process. So let's go ahead and check this last one. We have 2y minus x equals 3x minus 4. Starting off the exact same way, I'll rewrite the equation. I know that my goal is to isolate the variable y. So in order to do that, I need to get rid of this minus x. So I'll do the opposite and say plus x to both sides of the equation. Now this time on the right, you'll notice that I have something to combine. I have 3x plus x. I can combine that. That leaves me with 4x, and then I'll bring down the minus 4. I'll divide everything by 2. Cancels out on the left, leaving me with y equals. Now when I get here, I have 4 divided by 2. Remember, you have to reduce if you can. 4 divided by 2 is simply 2, so that becomes 2x Then I'll do the same thing here. Remember to look at the sign that's in front of the number. So it says minus 4, so we know that means negative 4. So I'll have a negative 4 divided by a positive 2, making it negative. So this becomes minus 2. I'll identify my slope. That's the number in front of the x. So the slope is simply 2. And my y-intercept, that's the other number. Make sure you bring that sign with it. It's a minus sign there, so it means that that is negative 2. It's a fairly simple process. Now we're ready to go ahead and start actually graphing the equations with our next example. Now in example 1, we had to well, actually in example 1, we didn't have to multiply either of our equations by a certain number. It was already set up so that we had a set of variables that were opposites. We already had that, so we didn't have to do anything. We had to just go ahead and go through the process to solve the equation. In example 2, we had to multiply one of the equations by a specific number in order to make them opposites before we could solve the equations. Well, example 3, we're going to have to multiply both equations by a certain number in order to turn them into opposites. Now, in order to do so, what you're going to have to do is make a decision. Which variable do you want to eliminate? And for this first one, I have the system 3x minus 5y equals 15 and negative 2x minus 3y equals 9. So I need to make a decision. Which variable do I want to eliminate? So for this example, I'm going to go ahead and eliminate the x's. And this is what I'm going to do. For the top one, I have a 3 for the coefficient. And for the bottom, I have a negative 2 for the coefficient. I believe what I want to do, I want to turn the both into 6. I want one to be a positive 6, the other to be a negative 6. So in order to turn the top into a positive 6, I'll multiply it by 2. In order to turn the bottom into a negative 6, I'll multiply it by 3. And clearly I think you can see all I'm doing is I'm multiplying the top coefficient by the bottom coefficient and the bottom coefficient by the top. I'm just doing vice versa to turn them, multiplying them into each other just to turn them to negatives, okay? So once again, what I'm doing is I'm going to multiply this top equation. I'm multiplying the top equation by 2. I'm going to multiply each term inside the equation by 2. So let's go ahead and change this one first. 2 times 3 will give me 6x. 2 times negative 5 will give me a negative 10y. And then 2 times 15 will give me, oh, let me fix that. 2 times 15 will give me 30. So that equals 30. Now the bottom equation, I'm going to multiply it by 3. Now when I multiply this 3 by each term in that bottom equation, 3 times negative 2 gives me a negative 6x. 3 times a negative 3 gives me a negative 9. And then 3 times 9 gives me 27. Okay, so now I'm ready to go ahead and solve my system. You see that once I did that, I clearly came up with opposite variables. So now I have 6x minus 6x, it cancels out. And then I'll have a negative 10y minus 9y gives me a negative 19y. Bring down my equal signs. 30 plus 27 gives me 57. I'll divide both sides by a negative 19. That leaves me with y is equal to, now 57 divided by 19 gives me negative 3. Now I have my y value. Now I know once I get one variable, I'll just substitute it into one of the equations, one of the original equations, and solve for the other variable. Excuse me. I believe I'll take the top top equation again. So this is 3x minus 5y equals 15. That's the original. So I know that y is negative 3. So when I get to this y, I'll substitute in that negative 3. And I'll finish off the equation. So now I can simplify 3x. Negative 5 times a negative 3 gives me a positive 15 equals 15. Subtract 15 from both sides. That gives me 3x. 15's cancel out is equal to 0. So of course if I divide by 3, that's just going to give me x is 0. So now I have my solution. My solution for this, my x is 0 and my y is negative 3. Okay, let's try the next one together. Now I'll need to move this up just a little so I can see my next equation. Okay, this time I have 3x plus 2y equals 10 and 2x plus 5y equals 3. So once again, I need to make a decision. Which variable do I want to eliminate? Well, in the last equation, I eliminated my x's, so this time I believe I'll eliminate my y's. So I have a positive 2y and a positive 5y for my variables. I need to turn them into opposites. So my top one, I believe I'll multiply it by a negative 5. I can multiply that by a negative 5, and the bottom I can multiply it by a positive 2. Now if I do that, this becomes a negative 10, this becomes a positive 10. So that will work. All I'm doing is I'm just multiplying the coefficients by each other. So they'll be opposites, okay? Once again, my top equation, I'm going to multiply it by a negative 5. And incidentally, I could multiply the bottom by a negative 2 and make it negative. It doesn't matter. As long as you are consistent, you should still come up with the same answer. The bottom, I'm going to multiply it by positive 2. So for my top equation, let me go ahead and multiply this negative 5 to each term. Negative 5 times 3x will give me a negative 15x. And negative 5 times 2y will give me a negative 10y. So y, let me fix that a little better so you kind of looks like an x. That's a negative 10y. And then equals, and then negative 5 times 10 will give me a negative 50. For the bottom equation, when I multiply each term by 2, 2 times 2x will give me 4x. 2 times 5 will give me a positive 10y. And then 2 times 3 will give me 6. Now clearly you see my x variables are now opposites. Okay, so now I'm ready to solve the equation. Negative 15x plus 4x will give me a negative 11x. The y's cancel out. Bring down my equal sign. And negative 50 plus 6 gives me a negative 44. I'll divide both sides by negative 11. My negative 11's cancel out, leaving me with x is equal to negative 44 divided by negative 11 gives me a positive 4. Now, by now, you should know the drill. Take one of the original equations. I believe this time I'll substitute it into the bottom equation. The original bottom equation is 2x plus 5y equals 3. And I know my x is 4. My x value is 4. So 2 times 4 is 8 plus 5y gives me 3. I'll subtract, I'll subtract 8 from both sides. Let me fix this. I'll subtract 8 from both sides of my equation. 8's cancel out, leaving me with 5y is equal to a negative 5. Divide both sides by 5, leaving me with y is equal to negative 1. Okay, so that means that my solution for this system is 4, negative 1. Remember that when you're putting your solution together, the x value has to go first and the y value has to go second because it is an ordered pair. Now, just like on the previous example, I want you to go ahead and pause the video at this point. Finish those last two equations by yourself, then restart your video when you're finished so you can check your answers. Okay, if you've restarted the video, that means you're ready to check your answers. The next system that we have is 4x plus 16y equals 14, and the second equation is 5x plus 7y equals 18. Now in this one, it really doesn't matter which variable you eliminated first, but I think I'm going to eliminate my x variables first. And what I'm going to do, I'm going to change one to 20 and the other one to a negative 20. So that means that I'm going to multiply the top by negative 5 and I'll multiply the bottom by positive 4. Okay? So the resultant equations, let me go ahead and write this down. I'm going to multiply by negative 5. The bottom, I will multiply by 4. Okay, so in the top one, negative 5 times 4 will give me a negative 20x. And then negative 5 times 6y will give me a negative 30y equals, and then 14 times negative 5 gives me negative 70. For the bottom equation, 5x times 4 gives me a positive 20x, and 7 times 4 gives me a positive 28y. And then I have 18 times 4 gives me 72. Okay, so now I can eliminate my x variables. Negative 30y plus 28 gives me a negative 2y equals, and then I'll have a negative 70 plus 72 gives me 2. I'll divide both sides by negative 2. And that gives me y is equal to a negative 1. Now that I know the value of my y variable, I'll plug that solution into one of my original equations. I'll go ahead and use this top one, 4x plus 6y equals 14. And now that I know that y is negative 1, I'll replace this with a negative 1. And I'll go ahead and solve this equation. This gives me 4x minus 6 equals 14. I'll add 6 to both sides. This gives me 4x is equal to 20. Divide both sides by 4. And this leaves me with x is equal to 5. So that means that my solution for this system is going to be 5 for my x value and negative 1 for my y value. Now if you eliminated your y variables first, that's okay. You still should come up with the same answer. Okay, now let's go ahead and check our last one. For our last equation, we have 2x minus 7y equals a negative 12 and 7x plus 5y equals 17. For this one, I think I will eliminate my y variables. And that's just simply because one is already negative and one is already positive. And I'll turn one to negative 35 and the bottom the bottom coefficient to a positive 35. So that means I will need to multiply the entire top equation by 5 and the entire bottom equation by 7. Okay? So, when I multiply the entire top by 5, that gives me 10x minus 35y equals a negative 60. The bottom equation becomes, after multiplying by 7, 49x plus 35y equals 119. Okay, so now I'm ready to solve my system. 10x plus 49x becomes 59x. Y's cancel out, equal, and negative 60 plus 119 is 59. I'll divide both sides by 59. That leaves me with x is equal to 1. Now, once again, same old, same old. I'll use one of my original equations. And I'll substitute the value for x, which is 1, to solve for y. Okay, 2 times 1 is simply 2, minus 7y is equal to negative 12. I'll subtract 12 from both sides. Excuse me, I'll subtract 2 from both sides. That leaves me with a negative 7y is equal to a negative 14. Divide both sides by negative 7. That leaves me with y is equal to negative 7 divided by a negative, negative 14 divided by negative 7 leaves me with 2. So my solution, my x value is 1 and my y value is 2.